So in this video, we shall be extending the functionality of the push buttons. In the video before this, and make sure you watch that video, in the video before this, we had an Arduino board and we connected one single button. So this one is going to be a very simple extension of the same, just to show you how you can end up mixing different variables. So we are not going to see a lot of change, but it's just a nice continuation from the previous video to ensure that you sort of understand the concepts behind it. So let's get started. So coming back to our same breadboard design, we'll start with another button. Can I duplicate? Yes, okay, so I'll just duplicate this. Oh, that's where it went. Just duplicate this so that we have two push buttons. One will be yellow and one will be red. And then we will get this push button to come from pin number 9. Yeah, pin number 9 to come to that push button. Let's just give it I hope these don't confuse you, but basically these wires are not connected to anything along the way. They are connected to that point there. So let's give this, let's give it a red. And then the other side of the push button is still going to come to the negative. We'll just put that as black. So in this case, we are going to get another push button and put a red cap on it. And then put them next to each other. Again, make sure your push button is seated firmly. And what we'll do again is that one side of the push button is negative, connected down to the negative. And then the other side of the push button is going to go all the way to pin number 9. The pin number doesn't really matter as long as you're using a digital pin. So you can use another digital pin, and as long as you set it to be an output or an input, it should be fine. All right. Then we are going to get our LED. We'll duplicate that LED. And let's put it on this other side to avoid confusion. We'll duplicate that same resistor as well. And one side of that resistor will go to the negative, and then the other side of the LED will go to pin number 12. Again, the pin really doesn't matter. We are just playing around with different digital pins. Let's give this a red. Also, the colors don't really matter. I'm just trying to create simple identifiers. All right. So this circuit ideally should work. So let's add our red LED. Let's add our resistor. We can just simply put this across like that. So I don't need another wire for that. And then we'll get another side of that resistor and connect it to pin number 12. if this is not clear, you'll see it on the illustration that will be shown separately, and then you can freeze the frame and just look at that separately. Again, this code is a continuation of the code from the previous video about controlling a push button. So in this case, we shall basically say yellow button is pin number 8. All right, let's confirm that in our sketch. Our yellow button is pin number 8, and our red button is pin number 9. So we then say int red button, sorry, let's just correct that, yellow, int red button is pin number 9. Then we shall again say yellow button status is 0. And then we create another variable for the red button. Red button status is 0. Right? So this code is basically saying that now we have two types of buttons. We have two different buttons. We have a red button and we have a yellow button. The yellow button is connected to pin number 8. The red button is connected to pin number 9. The status of the yellow button is initially 0, and the status of the red button is initially 0, which means it's off. Then we go to the void setup again. We do the same thing. We do pin mode. In this case, yellow button set to input pull up. If you don't know what input pull up is, just look at the previous video. It doesn't explain it fully, but it does explain a little bit of what it's doing. And then pin mode for the red button should also be input pull up. Now, here we created a pin mode for pin number 13, which is connected to the onboard LED on the Arduino, right? And we have designated it as an output. So what we are going to do is, instead of using the numbers, let us go back and create a new variable that says yellow LED is 13, because that is connected to pin number 13. And then the red LED is connected to pin number 12. So int red LED is connected to pin 12. So in this case, pin mode 12 is an output. Right? So to recap the code, we have the yellow button designated as pin number 8. The red button variable is designated as pin number 9. The status of the yellow button is 0, which means it's off. The status of the red button is 0, which means it's off or it's not pressed. Then we have the yellow LED assigned to pin number 13, the red LED assigned to pin number 12. And then we have the pin mode, which is basically assigning a specific mode to that pin. So the pin for the yellow button is a pull-up, meaning that we have the yellow button, which is on pin number 8, being designated as an input, but a special type of input called a pull-up, which basically creates special functionality that allows it to be a clear 0 or a clear 5. Then pin mode for the red button is also an input, but it's also an input pull-up. Then we now go to pin mode number 13. In this case, we are going to replace it with yellow LED, because that's where our yellow LED is connected. We designate that as an output. Then pin mode for 12, which is red LED, we designate that also as an output. All right? So we've created our setup. Now we go to the loop. We want to read the button statuses for both buttons. So we're going to say yellow button status is the digital read value of the yellow button. Now you need to be very careful about your cases, basically whether you capitalize or not. If you put yellow button with a capital B, and here it is a lowercase b, then Arduino is going to tell you that it doesn't recognize it. So you have to make sure that the same way that you've written the yellow button up here has to be the same way that you've written the yellow button down here. So then we have red button status equals digital read red button. Very simple. So at this point, you're reading the status of the red button and the yellow button to see whether they've been pushed. Then, if the yellow button status is high, then digital write yellow button, actually yellow LED. So now you are reading the yellow button status, and then you are assigning the LED a certain value depending on what that status is. So in this case, if the yellow button is high, meaning it's not pushed, then that means that the yellow LED should be low, which means off. We'll do the same thing again. If the yellow button status is low, then the yellow button should be high. So we'll copy all of this and do the exact same thing for the red button. So then we shall say if red button status is high, then the red LED should be low. If you're wondering why it's inverted, it's because the way that the pull-up function works is that it switches things around. So if the button is pressed, the LED is supposed to turn on, but if you just write that code like that, then it's going to be reversed. So you press the button and the LED will go off, and then you release the button and the LED will go on. So we need to invert it, and that's why you have this high in opposite to the low. So in this case now, the red button again, the red button again. When the status is low, then the red LED button should be high. Right? So let's test this. If I've not made any mistakes, it should work flawlessly. So we have that. You see the yellow LED is on, and then the red LED is on. So if I press both of them, we should see both of them come on. Now, we had a bit of trouble in this particular experiment, and I want to share it with you because it's very, very critical that you understand. Typically, in a typical breadboard, you have these rails. So like this can be a positive rail or a negative rail, and some of them are color-coded like this. You'll have a red, meaning this is the positive rail or positive line, and you'll have a blue or black, meaning negative line. Some of them may not have it, but it still serves the same function. Now, one thing you need to be very mindful of is that for some breadboards, this entire thing is connected. So when you plug something in here, it will also be connected to anything that you plug in here. If you plug something in here, it will be connected all along this top line, all the way to the end. In some of them, however, there is a break in between, meaning that what you connect along this line will not be connected to what you connect along this line. So for some breadboards like this that are color-coded, you will see that this red line starts from here and ends in the middle, and then the next one continues from here and ends on the other side. For some of them, you'll see one straight red line all the way. So this is indicative of whether or not there is a full connection at this point. So for this particular breadboard, there is no connection at this point. So one of the issues that we had is that I had forgotten about that and kept assuming that this group of LEDs were connected to this positive and negative, and yet it wasn't the case. It's an easy mistake to remember, and it can save you a lot of troubleshooting if you just remember that. For some breadboards, you will find that there's a break, meaning that this side of the breadboard is not connected to this side of the breadboard. For others, you'll have one long connection and there'll be no break. So always make sure that you test for that. Shout out to Michael, the editor, for pointing this out. So again, this is just another simple extension to the previous video. It's nothing fancy. We are just adding variables and reading different buttons on different states. There are ways that you can extend these button tutorials, and we shall do them in the next video. But for now, I hope that you enjoyed this button experiment, part 2, and we'll have a part 3 and a part 4, and they will extend the functionality that we've studied today. So thank you for watching, and see you in the next one.